Okay, so got half an hour, and I took the brief quite seriously. So I want this to be an interactive session. If it's not very interactive, we might get another break pretty quickly. But quick show of hands, who here saw my session at Virtual FDS? The answer is yes for you. Who saw my session at Virtual FDS? Yeah. So not many. I'm not planning to go back through it because it was a 40-minute session and this is only a 30-minute session. So I'm not going to cover everything, but there are links, and I'll just go through the basics. So we've got our bearings, and then we'll wander through it. So in that session, the whole presentation, there is a demo. So just to bear in mind, there's the stuff that actually kind of runs and works. And what we want to get out of this session then is, well, where do we go from here? So we've solved a specific small pain point, which was that there's lots of really great open data on Filecoin. It's a really great place to store that sort of stuff for longevity, for long periods, for humanity, and everything else that we've used over the years. But it's really hard to find. And the specific sub-niche of that hard-to-find problem that we were looking to solve was specifically for Phil Plus, where allocators give data cap to clients and then SPs with these open data sets that are considered worthy and valuable and great to store. But it's really difficult then to assess compliance. So just bear in mind as well as we go through this, and when we have thoughts, we've solved a sub-problem of a sub-problem of this visibility, but we've done it well, and we now want to build on that to be more positive, not just policing Phil Plus deals, but also, how do we get everybody to actually use it? How do we get it downloaded? How do we get a reputation for Filecoin as being a place where people actually go to find and download and use humanity's data, and not just using it as a cold sort of offline sink for large data sets and things like that. So with that in mind, the big part of the problem that we found first and foremost is, well, if there's no standards and interoperability, then it's really hard to corral everything together. So standards and interoperability are king. To that end, we created a thing called TOADS, which is the Open Access Datasets standard. And TOADS consists of 3 parts. Again, if you're interested in this kind of stuff, this is in much more detail in the presentation from Virtual FDS. But there are essentially 3 parts. There is a manifest spec, talking about how we actually describe these data sets. And this is the bit that we are really protective of. So the whole point is there has to be interop. Everybody has to prepare their data sets and describe their data sets in the same way. Otherwise, you can't build tools and you can't build any analysis and you can't search for anything. So we're very protective over that. And this is the place, the sort of totem pole that we want to dance around. If you want to make a change, you're very welcome to, but do it through a PR in that one and only repository so that we continue to evolve a standard and not the 14th standard. Then there's some reference tooling. Reference tooling we're not that bothered about. It's just there to make life easier. So it's a good way of finding out how to manipulate and use the standards. It's based almost entirely on existing Filecoin universe code. So we've used a bunch of IPLD libraries. We've used a bunch of stuff from Storacha, and we've used a bunch of stuff from Philoz. So there's very little in there that's odd or weird or won't evolve alongside everything else that's evolving. But if you want to fork it, if you want to chuck it inside Singularity, if you want to do something else, go for your life. We're not that protective of that. And then there's an example directory, which is very cool. We need that to kind of push the market forward. But so I'm wearing my special branded kit today. I work for Fiddle. Fiddle is not particularly interested in being the owner or the place where directories live. We're definitely not interested in paying the data fees or the transit fees for serving actual content, which would be kind of contrary to Filecoin anyway. So we've built a directory because you have to have something to start with and to prove the point and to make sure it works and to make sure the standard is developing in an ergonomic way. But actually, we expect there to be loads of places where you can actually ultimately find data sets, get them, download them, pay for your Phil CDN retrievals and whatever else. We're not interested in getting in the line there, but you have to have a way of listing and finding and discovering what you want, and that's what our directory does. So, because not many people saw the thing before, the quick idea of how this thing goes. The manifest is a JSON file. It is not currently stored on chain. Bloody huge, in principle. And it's organized into a handful of bits. There's the big manifest, which has there's more details. I don't pay too much attention to the specific details here, but you've got a kind of header that describes the data set itself. Very important thing to note here is that it is a data set, so you have to consider it as like if you go to Kaggle or Hugging Face or somewhere like that, or you go to openaccess.gov and you want to download election results, you have a lump, which is a coherent data set, and you kind of want everything in there to get access to the whole thing. Of course, you can pick out individual files. If you want sort of election results by county, you can do that. But you describe this data set as a coherent single thing. It's not intended to be a copy of a disk image where things change, minute changes every 5 minutes. And then there's a bunch of contents listing the pieces and what's in the pieces and various other bits that I'll go on in a minute. And then, again, the directory that we've built, it's running. You can play with it if you want. But the point of this is to provide a central place where you can find these things, but not actually like download or cache them or whatever. So the point is that the very last step of the tooling we've built uploads to an open public endpoint that just sends the manifest up. And then we display all these things. And when you get to the point of saying, oh, I kind of like this matches the tags, this is an organization I trust, because we know all the pieces that it's stored in, you then go to the standard Filecoin tools or whichever of the dashboards you want. And if they've been advertised correctly on IPNI, or if they've been registered somewhere else, you can actually get them back again. So introductory service, but then everybody's in control of actually where their data is, how many copies you've got, and so on and so forth. So we ended the virtual FDS session with a call to action of, where do we go from here? We have created the agile skateboard of open access datasets, discoverability and standards to solve that very specific problem of like, if you are promising that you have a thing which is always available and public, we need a simple way of checking where it is, knowing where it is, and making it easy for people to comply. Because the compliance issue on Phil Plus always sounds like policing, and it often sounds kind of negative. That's not the point at all. The point is to make it easy for people to prepare and advertise this data in a single, like it's a one-liner on the CLI. You don't have to think about anything. It's completely standard Filecoin tooling, and then off it goes. So we just make it super easy to do what you're supposed to do if you're getting data cap for open access data. But that is only one small part of the puzzle. We do want this to be bigger and more interesting. And I guess the key thing, which this isn't the first or last time I'm using this picture in this week, we need to evolve it slowly so that it's useful every time we change something. If we try to boil the ocean, that just never works. So where's the next step, and then the next step, and then the next step, so that we've actually got lots of useful things. So I had some starters just to stimulate interest, but I only have 2 more slides, and then I'm going to hope that people in here start talking. So a few things to consider. So this is the actual manifest standard. It's maintained in GitHub. There's obviously much more detail, but this is kind of the top level thing where we have this dataset metadata, and then it includes, after all the sort of the basic stuff, it includes an array of pieces. So how many pieces is this in? It's designed for very large data sets. It's been tested up to very large, like million file and hundreds of gig data sets. So it's designed for very large pieces. So you can have many 32 gig pieces in there. Equally, when I was first doing this, I was trying to find data sets that were that big. And if you go to the standard data warehouses or the AI training or whatever, it's pretty hard to find something over 32 gig actually, in most cases. So it's happy at a wide range of scales, but you've got an array of pieces, and then an array of contents with a few kind of simple, interesting things. And as a sort of starter for 10 or 20 or whatever. I'm interested in a couple of different points of view in this session. I'm interested in use cases and just doing more with Filecoin and FOC is an interesting crossover, because I know there are some advertising and there's the on-chain metadata and stuff in there. So I want to see how and if those overlap. I'm also interested in precise technical changes or precise technical input to how this thing's designed in the first place. So as some starters, we really don't, so this open with thing, we're not in the business of defining standards for the data itself, as in, if I've got a long string of numbers, how does that turn into a graph on a screen or an image in an image program? That is entirely up to whoever is interpreting it, but you need a hint somehow. So if it's the geospatial data and it opens in ArcGIS, we want to say that. However, numerous attempts have been made to standardize this in numerous different SDOs, and it never really works. So this is an example of a few things that we've put in there which are currently kind of free texty. So we've got a standard for where you put it, but not really a standard for what you say once it's in there. So some input or ideas on constraining that or not is kind of very interesting to us. We include the payload SID, and as has already been said today, payload SID is not necessarily a reliable or real thing. It only works for market deals. We can always work it out because you're using the standard car tooling and the packing tooling, so we always know what it would be, but it's not necessarily reflective of what's actually been part of the deal. So question marks over that. And the most controversial of all in the current reviews that have happened is this hash. So in the list of entries, these are the Unix FS nodes, but think of it as a file. So you've got a PDF, and we'll give you the byte length. We'll give you the SID of the file. This would be application PDF, and the piece SID that it's in, so that it's easy to find. We kind of cross-reference things all over the place, so you can very quickly find it, especially in a large data set. You want to do a partial download. Where is it? What's the thing? What's the range? And I can go and grab it. That's all cool. We've also included a SHA-256 hash next to the SID. The reason for that is completely redundant cryptographically and mathematically, but I personally think it's interesting and put it in there because most people's standard tooling will include a very simple command line pipeable thing that can check SHA-256 hashes and might not include stuff that understands Filecoin SIDs, especially we start going down the road of not doing SID, doing SID v2 or doing some of these other hybrid multi-hashes that are being described. So a few things in there that I'm interested in feedback on. And otherwise, so if you actually are still in this room because you're interested in data discoverability rather than just sitting here after lunch, the kind of thing I'm interested in as feedback, input. It can be questions, it can be criticism. I don't really care, but I'm interested in input on how we move more of this on chain, whether we need to, I don't know. But at the moment, we have these very large JSON files which float free. And the very next thing you do once you've got this JSON file is you go to the chain. But the manifest itself isn't on chain. So can we do better there? Other use cases for describing data sets other than the public open ones where we're trying to kind of aggregate and stimulate demand and stimulate usage? Are there other use cases we should be optimizing for? The preparation is extremely opinionated right now. So we totally assume you're using right down the middle car v2 with BSIDs and COMPs and everything else. We've already heard today from Rod about ideas of maybe we don't need car files, maybe we can use direct bytes, whatever. I don't mind what happens there, but if that becomes a real thing, we probably need to accommodate it here. And lastly, just to make the point that the Toads tooling will live on. It's doing a good job in Phil Plus already, so that's kind of a given, but I don't want to push it. This isn't an advert for that per se. It's just to say, well, we've got a nice starting point. If we can evolve that, then great. Equally, are there other use cases or other kind of data set description discovery type tools that we should be building in Filecoin and not doing with the Toast tooling? And just to keep things on the level, we always start with why. So I accept there are lots of things we could do. What I'm looking for is input on what we should do, because there's actually a need for that. So that's all I prepared, I think. Yeah, then it's back to Rod. So, yeah, any input? Does anybody have any needs, extant ideas for dataset discovery?
Hola.
Yeah, that's loud enough.
And this is recorded, right? So I don't need to like remember and write shit down.
I have maybe just a little bit on bullet 3. When you're talking about non-car v2 or using car v2, it's very Filecoin specific.
Yes.
Like Rod was talking about it, like storing bytes directly or storing blob data. That's what we do today too at Akave with PDP.
Okay. Yeah.
So putting it in a bucket of prep is maybe not the right wording if you're going to add bytes of data and blob data, but there's no prepping involved.
Yeah.
That's all I'm trying to add there.
Maybe that's justification for my SHA-2 hash.
Yeah.
Maybe.
Yeah,
no, it's a good point. So I'm also in touch with the sort of more raw IPFS community. So I've got some feedback on this from the SID Congress community a little while ago, and there's another SID Congress just after this that I'm going to. So I'm mindful that we could do something pretty powerful, dropping down to the raw IPFS level. At the same time, I was just trying to solve that one fill flush problem first. But yeah, this is just all good input. That the more of those kind of use cases there are, the more we should support that. So thank you.
Don't be shy. Ian, I'm coming to you.
So I think this is mostly a question for the Philaz team. So if we have to build your dataset explorer on chain, all we really need is a way to store an array or an unordered set of those manifests, and then maybe provide some simple search on top of that. The search part sounds kind of hard, but what kind of services would we need to build to have like a Filecoin on-chain cloud set management service where you can add a new manifest to this set and you can pull the full list of manifests from the set easily?
Does anybody know? Rod's he's getting the mic anyway.
How's that? Yeah, I was distracted for the moment that you see.
So John proposed basically like a simple data set browsing interface that lists a list of data sets that are all defined by these manifest files. Those manifest files then link out to other CIDs. In order to put that on chain, we would need something in Filecoin on-chain cloud that's basically like a manifest set management interface where we can like add things to a set and then get back the full list of things in that set easily. How much would we have to build to get that on top of what you guys have already built?
So the thing that I would really be excited for people to explore, now that it's easier to add smaller pieces quickly, I would love people to layer indexing within pieces. So instead of thinking about how can we put this on chain, how can we get new structures on chain, put the structures in the storage. So index the storage within more storage, and you have this layer of indexing. And you can use metadata on chain to point to where the indexing is, but you should be able to you just go to the chain to find the metadata that finds you the first hop to get to the storage. You pull the storage out. That's an index that points you to the next layer. So we should be able to now build indexes of indexes of indexes that let you reference huge amounts of storage. So we don't have to do it on chain, but the chain can point you to where to start.
Right. So we can have indexes of indexes of indexes. I guess my question is maybe just like, how do we do IPNS with FOC? Like if we want a single pointer that a web app can go to load current list of something.
Yeah.
And we want to update that list over time with a new pointer to a new manifest on Fox somewhere. How could we do that?
Yeah, there's multiple ways, but the one that I've been mostly interested in is using the metadata within datasets. So like I like to imagine a theoretical Dropbox replacement where I run this thing on my computer and it's constantly making new pieces with just the changed things and shoving it onto PDP. But it maintains a local database of what's been backed up and what the file names are, all that sort of stuff. But that database is also backed up to PDP as well. And then so I lose my computer, but I can restore it just by going to the chain, finding and letting the metadata tell me within my list of data sets and pieces, tell me when was the last database that was backed up. I can fetch that, there's my piece, pull my database, restore everything from that point. So you can use the metadata on chain to find the latest of the thing that might be the latest index of it. So you can,
So I think, so if I get you correctly, forgive me cutting you, but I want to repeat this back so I know I've understood it. So we have currently this organization of the super manifest, which is the entire data set, and then we do actually store the manifest in the pieces, but they're currently bloody big pieces.
Yeah.
So what I think you said about using FOC is that we could even have a super duper manifest. So whatever, we currently have a centralized service, very, very simple centralized service. It's just a gateway to FOC. You upload a list of all of these, and because FOC knows what's the latest one, we can go back, fetch it, get the entire list of all of them, and then say, here's all the manifests, and then they go from there.
Yeah, and you could do this, like you could have a dedicated data set that just stores the super manifests, and the latest piece in that data set is the one. And you can delete pieces as well. So you could have a data set that only ever contains one piece, and it just keeps on getting updated, and the old ones get deleted. You could do it that way. But these things are ordered on chain. The metadata can help you with that. You could put dates in metadata. You can put whatever you like in the metadata to help you identify what the one you want is. If these things get big and it's like every time you're uploading your new manifest, super manifest, and it's like you're repeating yourself every time, that's when you can use IPFS and you can bundle it in the car and you get deduplication magically.
Yeah.
So use IPFS for making these things lean. So yeah.
Yeah, so that would be an easy experiment to run out. Let's do it.
Yeah, but think about when you're building these applications with all this metadata that points to like all these indexing structures. Think about how to get them into storage as well, so that you don't you need local state for a lot of these things, but that local state could also be backed up to PDP. So let's think about how to layer these indexes.
I'd like to add something, maybe a little plug to Akave as I work there, but so we actually do a little bit. Well, actually, we do it that way at Akave, right? Like because of performance issues, we built the manifest of the entire data set. We put the manifest actually spread out over the blockchain, so it's kind of pieces and bits of it, and then the nodes index it as in a database, so they can always recover when the node fails or whatever that is. But like on the PDP side, it goes the same way, right? When the node's offloaded or stored on PDP, it also has an indexed manifest locally to locally know where its own data is. But in case it fails, it still has a way to rebuild it. And what I'm trying to get at is that if you do indexes of indexes, it gets really slow if you don't do some cached index or something like that. That's something that like a node or something that's reading the data off, or the application can rebuild from somewhere. So what I'm trying to say is, like, in the manifest organization here, when you're writing out a spec, something to add would be interesting to see is like, how do you spec out basically the recovery of that manifest? How quickly can you do that, or how would you build that?
Yeah, indeed. And I think that sort of leans me a little bit towards having
You're good.
a super lean, the one that you were talking about. So just as an aside, my entire experience of FOC was building this container registry, and a container registry is nothing but manifests of manifests. So I've done this thing little bit already, and I like what you were saying, Rod. But I think the way I think I would approach this, because I'm going to go away and write it and see if it works. So again, it's kind of more confirming with people who know more about FOC than I do. But I think I'd rather have individual manifests as individual pieces, because they do get quite big, and the pathological size, according to our design constraints, they could be a gigabyte. If you have like 1,000,000 1K files, this JSON gets pretty bloody huge, and I don't want to be adding that to a huge bundle and removing an older huge piece every time. But having lots of middle-sized pieces and then one very, very efficient manifest that's constantly updated in the same way that the Docker does it, I think would work very well for me. And I just need to play with how the metadata works in FOC.
I think to the point of efficiency, I think these are all trade-offs, right? And you can treat your backup as the slow hydration if you need the full recovery.
Yeah.
But you can dial the knob anywhere between that. You could store these massive snapshots that tell you that you can restore straight from, or you could it's like you could do a keyframe approach in for video encoding, where you do little updates and then every so often you do the full thing. It's like there's been a bunch of experiments with on top of IPLD of building databases that are essentially append-only logs. And that's a really interesting model to think about here, because append-only logs are, it's essentially like a blockchain. To get the current state, you have to start from the beginning and play it all the way through. That's super inefficient, and nobody really wants to do that. So that's where it's both snapshots, but also local, the local view is the one that you care about. As long as it's in sync with what you've backed up, that's all that matters. And then if you get to the disaster recovery phase, then maybe you have to start from the genesis of it and replay every action. Or maybe you have a snapshot you can go and fetch to help you start from some point there. But these are just all trade-offs you have to play with and figure out what the right version of it is.
Cool, good. And I saw somebody, was it you? Somebody was editing on-chain cloud documentation a little bit earlier. So does anybody know if the metadata, so I'm interested in the on-chain metadata for OT pieces, things like the efficiency, things like, does gas cost grow if it gets really big? Is it actually searchable? Is that stuff documented somewhere yet?
I don't know if it's documented, but there are limitations on metadata number and size. It does slightly, it has a minor gas impact by doing lots of metadata. You are best off using subgraphs and off-chain indexes to fetch them, but they are searchable if you do lots of ETH calling to figure things out. But it's the kind of thing that you would probably use a subgraph to find what you want.
Great. Cool, that's all very helpful. I've got something to do. So yeah, couple of minutes left. Anybody else have problems, interest with datasets? I'm interested in private ones as well. I'm not convinced there's a need for any kind of standard or interoperability with indexing private datasets, but maybe there is. Other than, I don't want to get in trouble with IPNI or anything at that level.
I was actually going to make a comment about IPNI that was different. Maybe this will get me in trouble. Is Will in the room?
No, Will's in the other session.
Excellent. The interesting thing about IPNI is that it's essentially like a key value store.
Yeah.
And you can just put arbitrary stuff in it. So IPNI could be used in novel ways to index your stuff. Like you don't have to go through the pathway where it's the PDP server that's indexing your IPLD blocks. You can do that, but you could also just report to IPNI just random stuff that you think is interesting, and then it becomes discoverable to you. Like doesn't have to be compatible with IPFS, Kubo, and the rest of it. It's just a key value store. So use it as like a starting point for discovery of.
Interesting.
Yeah.
Yeah, I think so. From what I am hearing right now in this discussion is that the data that's being aggregated here, it's more on a granular technical level, like manifest files or what the data actually is, and making like a uniform standard around it. I'm interested more towards the end user point of view on is there a plan to categorize this? For example, let's say there's like some universities data
Yeah.
stored. So like how does the end user categorization or visualization
Yeah. So
works?
the wonder what's the can I zoom? I can't zoom in on this, but so the idea that the fields in this technical specification are intended for discoverable UX. So the idea is, yeah, there's a few like Internet Archive, super mature. They've got tons of experience. They've already worked out how to do this, and there's a couple that have, but most of these university sets haven't. And so the spec is designed to allow things like tags, and you can then just filter on tags. It's designed to allow, you have a domain in there that says the owner of the data set, so you can find everything from harvard.edu or whatever. So it's absolutely designed for those kinds of ergonomics. And for a user who doesn't know Filecoin and isn't starting with a CID or something, they don't know what they're looking for. So it is absolutely designed with those user ergonomics in mind, and the idea that I'm going to find the needle in the haystack. But again, yeah, we've tested it with like 10 open data set owners. We need more input. So if there is other input, especially on this question with the sort of not very well specified content. So we've got really well specified keys, but the values are kind of free text and a bit floaty. If there's good input or standards that we can follow there, I'm very interested.
One last part, or like for example, on the data cap stats website, let's assume like there is a data set or like listed like 1.2 petabyte.
Yeah.
So like the 10 that you mentioned that you tested, was there a metric around the retrievability or how to actually get that data, or is
Yeah,
that
so we have that already. So one of the niche problems that we wanted to solve was like, you have to pass these retrievability metrics in order to qualify for the data cap and whatever. Yeah, it's a bit more complicated, but it's morally, right? You are supposed to be providing this data set. And one of the issues that we have is that the SPs might very well be complying, but if everybody's using a different standard and putting things in a different place and advertising slightly different CIDs, it's very difficult for the network as a whole or for network participants to check that retrievability or to get it back or to provide that value to the world for a random user who wants that data set from the university. So, yeah, I mean, that was a huge part of it, is we've already got retrievability, and Spark still exists, and they get this thing called RPA, which is another way of testing retrievability. So we haven't added that here, but what we've done is made a standard, simple way of discovering so that those tools work uniformly.
Thank you. Any final thought, John, to wrap it up?
No, thanks very much. Thanks, Rod. That was very helpful. Thanks, everybody. Akavi. Yeah, I've got a little project to do, so that's cool. Thank you.